So this workshop is about command line tools in HPC environments. And my name is Xiaoqing Huang, and I'm with the IDRE RTG group. And as I said earlier, in this workshop, please ask your questions using this Google Doc link. And the link has been posted to the chat box. If you don't see it, please ask in the chat box so that people who have the link can repost the link. And there's another link that is a survey, and I'm hoping you can submit the surveys. This survey is about the topics of our future classes. And as much as possible, let's save the Zoom chat room for announcement or for important thing I want everybody to receive. So let's get started. So about this topic, if we kind of dissect the title and also that will kind of reveal what I'm going to talk about. And so I say this is essential command line tools. Of course, the word essential is a little bit subjective. And I'm talking about these tools from my perspective. And I have been writing programs, writing text for years. And these are some of the best tools that, from my perspective. And and the title also said these are the command line tools. So by command line, I will define what command line is in a minute. So for now, let's kind of think about command line as some kind of text terminal-based environment. So you type text into a terminal. And of course, the terminal may mean different things in different operating system, but that's what we generally mean by command lines. And the tools, there are so many command line tools. And so essentially in this workshop, if you can only pick up 3 things from the workshop, please remember these 3 tools. These 3 tools are to my knowledge, some of the best tools in HPC environments. And if you have not mastered them, I certainly recommend you to look into these tools. And if you can master the tools, they can probably change the way you work and increase your efficiency quite a bit. And also, I'm talking about these tools in particularly in what I call the HPC environment. The HPC environment is a general, let me mute. It's a general term, and so that means this, in a very broad sense, this includes your computer, your lab's computer, or the UCLA Hoffman 2 cluster, and also maybe you have access to some cloud services, Amazon, AWS, Google Cloud, and so all of these tools, what I call the POSIX conformant, and we will see what this means. So this kind of environment is what I kind of loosely call HPC environment. So these are the kind of the general thing that I will be discussing in the next maybe 1 or 2 hours. And so before I start, let me also lay down some terminologies. And I apologize if you already know these things, but I want to kind of lay the foundation for our discussion. So POSIX it stands for Portable Operating System Interface. And there is a formal definition for this, but for now, or for the purpose of this talk, you can think of, if you are using Mac, Apple Mac OS, or if you are using Linux, you are already operating in a POSIX environment. If you're on Windows, you can consider something like Cygwin or the like. So with this kind of environment, these are all POSIX or POSIX conformant environment. And so in this kind of environment, there is a large set of common tools that can be used across all of these environments. And also I will mention the name command line interface multiple times. And again, for the purpose of this talk, just think of this as the terminal, or some people call the shell. And that's probably enough for the purpose of this talk. So basically some terminal that you type command into. That's what we mean by command line interface. And also I will be talking about a graphical user interface, or GUI, and also there is a text user interface, a TUI. And from time to time I mention HPC, and the original name for HPC is high performance computing, but in here, let's kind of think in a broad sense that this means something you do, some kind of task or work you do in general computational data sciences. And the slide will be available after the workshop. And if you are interested, once you have the slide, you can click on this link. This will have the formal definition of what POSIX tools are. And so we kind of live in the graphical interface environment these days, right? So everybody, or almost everybody, has a smartphone. And the smartphone, everything is nice and good. And it's very intuitive, easy to use, user-friendly. But however, a graphical user interface can be restricted in the sense that, for example, on this graphical user interface, suppose the task I want to do is, how do I get the list of the files that I've created? And this is such a common and simple task, but it's actually quite hard to do, or you cannot do it in a few seconds in this kind of environment. And because the environment may not have the exact button that will do whatever you want exactly. And so simple things may become complex, right? So simple things like this, which is very common in data processing or programming, but you cannot easily do that in the so-called user-friendly graphical interface. And the situation is more obvious in the HPC environment, because in the environment, we do programming, data analysis, or writing text, writing reports, writing papers. And these are what I call a programming-oriented task. And also there's a kind of another secondary issue is that these days you probably access your computer remotely, right? So if you access the computer and you depend heavily on graphical interface, that can also introduce quite a bit of overheads for that remote connection. And so by viewing all of these factors, there is actually a good alternative, that is to use the text user interface tools. And actually the advantage of the text user interface tools are more than just a lightweight solution to these problems. Actually, it is much more flexible, as we will see. And so here, I'm not suggesting to reject all of the graphical user interface tools. We live in the graphical user interface world, so we use that as appropriate, but just do not overlook some of the powerful text user interface tools that we will be talking about in this workshop. So here is just an example of a graphical user interface. And this particular one is kind of interesting because there are text-based user interface embedded in the GUI. So in this desktop environment, this is obviously a graphical user interface. I have multiple windows, and Windows is one feature of the graphical user interface. So in one of these windows, for example, this Windows where my pointer is pointing on, I have an editor, and this is the editor that we will be talking about in a few minutes. And I open a file, and this is a program, and the text are highlighted because the syntax is recognized by the text editor. So it's very easy to see different categories of keywords. For example, the include is in a different color from the header files. In another window here, this is another text terminal, again, embedded in the graphical user interface. I have a command to list my files. And also, I'm using a technique called piping in this shell interface we will talk about in a few minutes also. The output of the ls, which lists my directory names, I pass this into a command, and this command actually runs another command that's called the DEU. It checks the size of my directories. So given a list of directories, which is output from the first command, I pass to the second command. And so the output will be the directory name with the size, right? So by this simple combination, I'm using two tools. I chain them together and I get the output I want. And this is very simple to do in a text terminal interface, but you may not have an exact icon in your graphical interface to do exactly this, right? So, and there are many cases like this, that simple things can be easily done in the text interface that you cannot easily done in the graphical interface. On the right-hand side, there is another application, and this is a drawing application. And here, this is a drawing program. So to draw something, we have to depend on other input device other than the keyboard. So this drawing program is controlled by the mouse or by the drawing pen. So this, to use this application, we have to use the graphical user interface. So depending on the purpose, there are scenarios that you have to use the graphical user interface, but in other kind of programming-oriented tasks, you find yourself heavily depend on kind of terminal kind of environment, even though you are operating in a graphical, kind of a global graphical user interface. And so this is kind of the environment we are in. And so in the rest of the talk, I will be talking about some of the tools that you can operate within the terminals. And also those tools can actually work together and kind of give you depending on your particular workflow, you can kind of compose the tools together to achieve very high efficiencies. And here I want to kind of point out some of the, what I call the human inefficiencies, right? So in the context of kind of programming kind of work. And when I say programming, I do not only mean writing programs. This also means you may write text, write the reports or papers from your computational or analysis. And so one of the sources of, ironically, of inefficiency is we have to use the mouse, right? When you are typing a text, your hands are on the keyboard, but if you find yourself having to reach out to the mouse, that can actually slow you down. If you only have to do this a few times, then that's probably fine. Using a mouse may be easier, but if you spend hours writing or exploring your data using the keyboard, by moving your fingers back and forth between the keyboard and the mouse, actually consume a lot of time. And this is funny, but not funny, is that you can also, some people have actually hurt their shoulder arms because of the kind of the bad posture by using the keyboard and mouse at the same time. So I like to kind of think about using the keyboard efficiently by thinking about how people play piano. Right? When people play piano, they use all 10 fingers, and you can see that you can actually do very complex motion by utilizing all of your fingers at the same time. And so one of the human inefficiency of using computer is you use only 1 or 2 fingers. For example, if you're typing on your smartphone, you're probably only using maybe 2 or 3 fingers. Or sometimes you just use the mouse, right? So if you can utilize the potential of all of your fingers, then you can, and also you minimize the travel between the keyboard and then to the mouse. If you can, your fingers stay always on the keyboard, and if you can do this if you can master this technique, then you can significantly increase your work efficiencies. So the big picture for today's talk, I will be talking about essentially the tools and the command line tools. And I will demonstrate a good use of text editors and the version control. and a very advanced terminal tool called Tmux, and their surrounding environment. And I will show by example how these things can kind of work together. And if you have not master some of these tools, I strongly recommend looking into them. Right? They can actually help you how you work and increase your efficiencies. And all of these techniques discussed are applicable to not only to the Hoffman 2 cluster that I mentioned multiple times, but also to other kind of server environment or on your laptop computers. And so the time you invest learning these tools will not be wasted. And also these tools are very, very mature. So you can expect to use the same technique once you learn it today, or you start learning them, you can expect to use them for at least the next 10 years without changing much. And so, like I said, we mainly will focus on the text editor, Tmux, and version control, and then we will show how to put this together. The kind of the characteristic of this kind of text command line tools is that they can be customized by configuration files. And there are hundreds, if not thousands of options you can customize these tools to your workflows. And everyone is different, right? Some people write a lot of code, but not so much text. Some people maybe just not writing new code, but you're just modifying a small part of somebody else's program or script, and you are writing your papers or analysis. And so everyone's workflow can be different. And so the advantage of this kind of command line tool is that they are highly configurable. So you can configure them to your particular workflow. And in the example I'm going to show in the next 1 hour, I have some setup that is configured to kind of the work that I do, and you do not have to do the same, but keep in mind that they can be configured to essentially any way you like to your particular workflow. And in case you are using Windows, Windows itself is not POSIX conformant, but you can consider some of the systems that can kind of make Windows more or less POSIX conformant. So I think Windows 10 has a Linux subsystem, and that is not a complete Linux system, but it's pretty workable. This is a useful thing to have if you are using Windows. Or you can install a Cygwin, and there's a link here. And there's a free software called Mobile Xterm. This is also quite good in a sense that it's very, very easy to install. And it's not exactly POSIX conformant, but it has many components of POSIX conformant environments. So these are some of the options you can consider if you are using Windows. And if you are using Mac OS or Linux, then you are already in a POSIX conformant environment. So you can essentially use the tools that I talk about in this workshop. So the first thing I want to kind of briefly talk about is SSH. So this is a secure shell. The secure shell is these days as a primary mechanism to log into compute servers or HPC clusters like Hoffman 2 clusters at UCLA. And this essentially operates as a client-server model in a sense that your computer, your laptop or desktop is the client of the SSH, and the remote HPC server or compute server is the SSH server. So your client connect to the server. And this is quite common in today's computing world. This is pretty much one of the primary mechanisms to log into a remote server. And so the kind of the mental picture of SSH login is that from your computer, you log into a remote servers. And I want to talk about kind of one alternative authentication method in SSH. So SSH support multiple authentication methods. The kind of standard way to authenticate or to log in is to use a password mechanism, right? So you apply for an account, or you get a hop into account, and you are given a password. You use the password to log in. That is the password authentication mechanism. SSH support another important mechanism that is called a key pair, and you may or may not have known this. So I'm going to explain the key pair mechanism, and this is actually a good mechanism to log in, and you can set it up so that you don't have to type the password again and again. So the way this works is that the key pair, by the name, you can see that it's a pair. So there are two items, and to be exact, there are two files. One is called the private key. This is a file, and there is another second file called the public key. And so these two is a pair, so they work together. And so the private key has to match with the public key when the login occurs. And this is going through the same SSH protocol, so everything is encrypted. And so if you create this kind of key pairs, essentially you can achieve a login mechanism without typing a password. And also you can do something remotely on the server, kind of without logging in. I mean, actually you get in and to run the command, but it will seem like you have not logged in. So I'm going to show you how this works. And because this setup will help the other tools that I will talk about later in the workshop. So the key pair, like I said, there are two files, and the file look like this. So you will use a command called sshgen, which I will show in a minute. And this command will generate the key pair, two files. The public key, this is a file that you copy to the server. The private key is a file that you keep on your computer. So when you try to log in, the SSH program will kind of take your private key and then match with the public key on the server. If they match, then you are in. And notice that the format of the two keys are quite different. The private key is just a multi-line file containing a bunch of kind of seemingly random characters, right? So this is the key used to encrypt your message. The public key is different, and the look is different. So the public key is actually only one single long line, and there are three items. The first item shows the format of the public key. So there are different formats for the public key. This is called the RSA public key. So there's a SSH RSA here, followed by space, and then the key itself. So this is a one single line. It's wrapped around because my screen is not so wide, but otherwise this is one single line. The third field in the public key is basically a comment field. So you can put in any comment here. So this is a good place to label what the public key is for, right? The private key doesn't have a comment field. So this is kind of how the key looks like. And the key pairs is not only used for server logins. If you use version control, and if you use some of the hosting repository hosting services, the key pair is also used for accessing your repositories. So for example, on GitHub, you can actually upload your public keys. So for example, I have two public keys here, and you can upload multiple public keys, matching some private key on some of your server, so that those servers can push or access your repositories through the key authentication mechanisms. So they are not only for server login, they can also use in other applications. And when you have multiple pairs of the keys, for example, from your desktop, you want to have a key pair to server A, and you have another key pair to server B, and so on. So you have to have a way to manage the key pairs. And a good way to manage the key pairs is to enter them into the SSH config file. So this is a configuration file for SSH client and this is used when SSH program look at this file to determine what to do when the connection is being established. For example, in this file, and this file is called config under the SSH directories. In these files, I have 3 items, and the first 2 items are keys. These are the private keys to my GitHub and GitLab servers. And this is the private key. The public key has been uploaded and added to my account in GitHub server. And the same applies to the GitLab situation. The third item is a typical server login. So for example, in this case, this is the UCLA Hoffman 2 cluster, the login node of the cluster. And here, of course, here you have to kind of put in your username of the cluster. And this field is the location of your private key, right? And the matching public key has been copied to the server, right? So with this configuration file, then we can easily log into this particular address without password, because the authentication is done through the key pair matching. So I will show a quick example of how this is done, and then there are some technical details. For example, you have to set the file permissions of some of the files, both on the server side and the client side. You can go to this repository, and there are some details that you have to take care of. Otherwise, the concept is quite simple. We use the command to generate the key pairs, and then put the key pairs in the right place, then you are ready to go, and you can log in without a password. So let me switch to my terminal. And let me go to my terminal here. Okay, so this is, I'm on Hoffman 2 login nodes, or this can be any server. And you can run SSH keygen command, and this command will generate 2 files. But in this case, I want to also want to insert a comment field into my public key. Like I showed earlier, the public key can contain a comment field, and you can put any text you want here so that you can label the public key only for your kind of information. They do not affect the key itself. So once you do this, run this command, it will ask you where do you want to put the key. And there's a default location, but it doesn't have to be in the default location. You can put in any place you want. So in my case, in this case, demo, I want to put in under these directories. And also the key file name doesn't have to be the default. You can rename the file any way you want, as long as you know what the name is and you put the name into your configuration file. It doesn't matter what file name it is. So when you do this, it will ask you to enter the key phrase, right? And key phrase, in this case, we are going to keep this empty so that we don't have to enter the key phrase. And also, we will not be required to enter password. So you have to do this twice, and then there will be some output, and you can maybe do a Google search to find out what this information, what these names mean. But in our case, essentially we have now 2 files, and this is a key pair, right? Like I said earlier, they work together. So if you look at the content of this file, this is your private key. It's a long string of kind of random characters, right? And every time you generate this, the strings are different. So this is a unique long sequence of random characters, and this is used to encrypt your message. The public key is a much shorter file, and it's actually 1 single line because of limited width. It kind of the lines wrapped around. Otherwise, this is 1 single line. And this is the RSA public key. This is the key itself, and this is the comment field that I entered. Right? So this can be anything. So with this key pair, then I can copy this file into a certain location where my configuration file specifies, and you will copy this public key into the server and placed under a certain directories. And with this setup, then you can now log in to the server. For example, I am now going to open a new terminal, and this is a terminal on my desktop, and you can, because I already have set up the Hoffman 2 login node, I can just run SSH login 1, right? And then I'm on login 1. And because the login is authenticated through the key pairs, so I'm all good. Now I log out, and also you can, in addition to just logging to the server, you can actually run a command remotely on the server. For example, let me clear this. You can run a command, for example, you can check how long the server has been up, right? So you are on my local machine, I basically run the command on the server through SSH. And because there's no password required, it looks like I can run this without logging in. And so this is all good. And you see that server has been up for 200 plus days. So this is pretty good. And also you can also do something like this. You can also see, I want to watch my username is this, and I want to watch the processes I'm running on login 1. So this is running in batch mode and repeat only once. So this is the processes I am running on the server, on the remote server, not on my local computer. There is a question about, there is a double factor authentication for the server. The key pair authentication method, when you use the key pair authentication method, normally you bypass the double factor authentication. So you do not do the double factor authentication. So for example, I have another server that I have access. The server has a double factor authentication. So double factor authentication means you have to, in addition to the password, you also have to, you will receive a notification on your cell phone, right? So that's a double factor authentication. And you can do that to log in. Alternatively, if I create a key pair, I will use the key pair to log in directly by passing the double factor authentication. Hopefully that's answer your question. So the answer is key pair works. And when you use a key pair, you do not need to use the double factor authentication. Of course, you have to keep your key pairs in a safe place, right? If I have your key pair, then I can log into your account without password. So the convenience comes with the responsibility. So I'm going to close this. And let's go back to the slides. Okay, so that's the key pair generation. And this talk is not about SSH, but I want to show this so that, and then this will help our later setup using other tools. The next topic I want to talk about is the shell environment. And again, this is not the main topic of the talk, but this will lay the foundation of how we use the tools later. So I want to talk about this a little bit. And I apologize if you already know some of these things, but I want to kind of lay out the foundation for everyone so we are on the same page. So the shell, or you can loosely think of as a terminal, and it's actually the shell runs within the terminals. They are not the same thing. The terminal is a program in your environment to kind of receive your input. And within the terminals, normally there's a shell program is running. And so the shell is a program that will basically interact with you. So you type command into the shell. The shell then interact with the operating system. And the operating system then kind of control your computer hardware, like CPU, memory, and other devices. And so this is how the whole process works. So you control, so you are basically, the user interface of the computer is the shell, right? So you are using the shell to interact with the computer. The shell itself is actually a programming environment. And just like a programming language, you can define variables and you can do many other things. You can write a loop, you can create a list, you can do a lot of things. You can also execute executable files, right? So if you are running some applications on a server, you are actually executing that executable files. And there's a whole process launching the executable files, but essentially it follows this kind of mental picture. You enter the command and something is triggered, eventually it loads the file executable into the memory and execute it. The shell can also be initialized just like any other command line tools. And there are multiple initialization files that control the default behavior of the shell. For example, one of the files called bashrc with a dot in front of it. And there are several others, depending on it's interactive login shells or it's not non-interactive login shells. But so the details here are not discussed in this workshop. I just want to pass by saying you can configure this to control the behavior to your like. An environment like this may look a little bit kind of old school, but actually it gives you infinite flexibility in the sense that, and as we will show later, you can actually combine or compose multiple commands or chain of commands to achieve a certain work easily, right? Which you cannot easily achieve by using graphical user interface. So that's kind of the value of the kind of the shell or terminal interface. And one important thing in the shell is the shell variables. And like I said, this is like a shell is a programming environment. You can think of a shell like a programming language that you know, Python or C or other languages. And in that programming language, you can define variables. And you can define essentially arbitrary variables in a shell, but there are certain shell variables, they are called environmental variables. They are particularly important because they control how the operation system work, depending on how you define those environment variables. So here, as an example, I want to show the importance of environment variables. I want to show that, so suppose I have a program, and we will show this in the demo in a minute, and the program is located somewhere in the file system. This program depends on a shared library. A shared library is something that the program has to load at the runtime. So when the program starts in the operating system, and at that moment, it has to load this file. If this file is not found, the program will fail. So to successfully run a program, the system or the operating system needs to know where to load the programs. Normally, in the POSIX conformant operating system, there are standard locations for the library, shared library files. So there's no problem to load those libraries. But in this case, because this is my own application and this is my own library, my library is placed under my home directories, right? So this is not one of the standard location for the shared libraries. So without additional instructions, the operating system is not going to know where this file is, right? Therefore, running this program will fail. For example, as we will see in the next demo, when you run this executable, and of course, this is a kind of dummy program, very, very simple, just a few lines of code just to demonstrate the point. But the same point applied to a general, like real application packages. you run the program and it doesn't work, and there's an error message showing something about loading the shared libraries. Right? It basically tell you that this is not found, and the program cannot continue. So the code, this program doesn't work. And let's see in the demo what's the cause and how to fix this. And the fix and then the cause are the fundamental reasons are that some of the environment variables are not defined properly. Therefore, the default behavior cannot kind of execute your executables. So let's see the next demo. So let me go to my demo location. Okay, so here I have two windows. On the bottom window, so this is a location of my libraries, and this is the library. And on Linux or POSIX conformal system, .so is a kind of a typical name for shared libraries. And so now I'm going to another window. So here, this is my application. So in this directory, I'm going to run full test, right? So this is my executable file. You run it like we see in the slides. There's something about cannot load the shared libraries. And this is because the shared libraries is located at a certain non-standard location. And to be able to find this location, I need to define a special environment variables, and that is variable is called LD library path. So this path include some additional non-standard paths for the system to look for shared library files. And obviously, if you look at this path, this particular path is not in the LD library path. Therefore, the system cannot find this. And the way to fix this is to add this path into the LD library path environment variables. And by the way, this is the name of the environment variables, which is one of the shared variables. And when we have a $sign, this means that we check the value of that environment variables. And before that, I want to have another command to actually figure out what's going on. So there's a command called LDD. This command display what shared libraries is needed for this executable. And when you do this, you see that this particular executable depend on 4 shared library files. 3 of them have linked to some addresses, but this one shows not found. So the system cannot find this particular shared libraries. There is a question about SCH. This is my username. SH is the name of one of the shell programs, and this is my username, and that has nothing to do with the shell. And just so happened that my username is very close to the name of the shell program, but they have no relations. Hopefully that answered the question. Okay, so this LDD command shows that this is missing, right? So we can fix this. So we are going to add this path, and bear with me. This is a long command. What I'm doing is I'm taking the old value of this and prepend the new path to it. And once I set this, if I run the LDD command again, you see that now this guy can find the shared library locations, right? And this is a non-standard location, not one of the system share file locations, but now it can find it because I have defined this into this environment variables. And now if I run the command again, now the program executes, right, successfully. So this is important of setting up some of the important shared variables to influence the behavior of how the shell execute programs. And so these kind of things are probably not so obvious, but they are important to the success of executing your programs, especially when you are using shared libraries in non-standard locations. And this kind of thing also has an implication. This means that you can actually install programs in your own home directories. As long as you set up those paths correctly, you do not depend on the system administrators to install programs for you. Right? You can always install everything under your user space and still can execute programs on your own. Right, so there's a question about whether this can be made permanent. So everything I do in this terminal will vanish when the terminal is closed. So to make this kind of thing permanent, you will have to add this kind of thing into the bash RC file that I mentioned earlier. To make the change permanent, you have to add those the path into the special RC files or related initialization files. Otherwise, in a new connection session, so once you terminate that particular session, all the settings is gone, and you have to put into the files. Okay, so we have some understanding of the shell environment, and we have some understanding of the text kind of command line. So we can kind of enter kind of our main topic today. The first of the main topics today is the text editors. And people have strong preferences about what editor they use. You may prefer some of the editor on your desktop or whatever you like to use. And so you don't have to use this particular editor that I'm recommending. But here the point of this demo is to show you that by using an advanced text editor like Vim, you can actually do a lot of things very efficiently, right? So maybe you can see some of the main point of my demos, and you can then you can consider what editors you should use. So this is just a logo of the Vim editors. And for text editors, one important thing to notice that a text editor is not a word processor. By word processor, I mean something like Microsoft Word or something equivalent, right? So they are different. In text editors, you edit plain text, right? And all of the programs or script or text files, maybe the source of your papers, they are mostly written in plain text files. And maybe you can write some kind of a structured notes or reports. And so all of this are the things that we spend a lot of time in, right? When you write a code, you probably don't write in one shot. You probably go back and again to modify the code, to modify the script, to modify the text files for your revisions. So all of these things also needs to be version controlled, right? To achieve the so-called reproducible computational sciences. And so on the right, this graph has no theoretical foundation. This is actually based on my own observations over the years, because I have also used various text editors over the years. So the vertical axis is speed and the horizontal axis is time. Although this is my own observation, I am pretty confident that many people who have mastered efficient kind of working tools in the HPC environment will more or less agree with me. So there are two curves here. The red one is the speed, like the speed, you can think of speed loosely like your efficiencies, your working efficiencies. working on this kind of files. You can, even with a new graphical user interface tools, it's very easy to start using it, right? Because everything is so user-friendly. You just click the menu buttons and you can do the thing that you want. So very easily, you can, in very short time, you can get to certain good speed, right, to make progress on your work. But then the speed usually will saturate. And the saturation happens because you have to depend on the mouse, and you constantly move between the mouse and then the keyboard, and you depend on the menu buttons. So you look for the menus to do certain things. Of course, you can install different kind of extensions or plugins to the editors to help you to work efficiently, more efficiently. There's a second curve, and that is the curve about command line editors, something like Vim, right? There are a number of command line editors, and I'm talking about the powerful command line editors, something like Vim or Emacs. These two are probably the most powerful command line editors at this point, and also over the last few decades. So initially, if you are really new to this, I intentionally show the curve to go to negative speed or negative efficiencies, because you may be looking at the manuals. Because these tools need some learning curve to get used to, right? They are not as intuitive as the GUI-based editors. But if you can master them, if you master a few techniques that are needed for your particular workflows, you can actually achieve very high speed and much faster than using the GUIs. And normally, in my observation, and this is not only myself, but also I have observed others, because in my position at IDRE, I also witnessed how many grad students or researchers at UCLA work. So the kind of initial hurdle, if you are persistent, the initial hurdle of using this kind of text-based editors may last only for 1 or 2 weeks. After that, your speed will be faster and faster. And at some point, and probably in the order of a month or two, you will be, with confidence, you will be faster than using the GUI tools. And these tools are also much more lightweight, so you can do a lot of kind of complex things very easily and very quickly. By the time you have done the task, the people using the GUI tools may be still clicking on the menus. And so here I say that this is the muscle memory, right? Because these tools are depending on keyboard operations. And just like I mentioned, like playing pianos, if you do this again and again, those keystrokes motions will become your muscle memories, but you don't even have to look at the screen, and you can perform the operations. In contrast, in GUI environment, you have to kind of move your mouse to click the menu items. So that can kind of slow you down. Of course, I'm not saying you have to use a text editor for everything, right? The GUI editors have their places. So if you only want to edit, if you do occasional editing, a GUI editor might be useful. But if you find yourself spending a lot of time doing a kind of text-based editing, I strongly recommend considering one of the powerful editors. And so on most kind of HPC environment, these three are probably available. And there may be others, but these three are probably available. The first one, the Nano editor, is quite simple to use, right? So if you just want to edit some simple thing without learning anything new, you can just use the Nano editor. The other two, Emacs and Vim, many people like Emacs and many people like Vim. Both of these are really, really powerful, right? No one probably can learn all the features in these text editors. I'm going to demonstrate some of the Vim features, and maybe you are using Emacs, but you can, I'm sure, whatever you have, you can do in Vim, there is something equivalent in Emacs, and vice versa. And so I'm going to demonstrate the use of this. And like I said earlier, these are advanced editors. They are initially may not be easy to use, but take my word that over time, you will be faster than using the graphical user interface editors. And all of these programs are open source programs. You can install any of this on your computer, right? So you don't have to use this on a remote server. You can install the same thing on your own laptop or desktop or lab servers. And so one kind of a secondary advantage is that then you can use the same environment across the board, right? On your own computer and on the remote server. So you don't have to learn different tools or editors on different computers. And these editors I expect to last for the years to come. So you don't have to worry about having to learn new text editors. So the Vim text editors, there are two versions, and there is actually a GUI versions, but I'm going to talk about the text versions, which just depend on keyboard operations. And if you are new to this, there is a program that comes with the Vim editor. It's called the Vim Tutor. So you just type this command, and then you can just follow the instruction. It will take you through some of the basic motion of the editors. And so you can, by the end of the tutor, may take, I don't know, a few hours, you will become reasonably familiar with the Vim editors. And I think they are equivalent thing in Emacs too. So one thing that is different, one thing that the Vim has that is different from many other text editors is that it has multiple modes. And you will see what the modes mean in my demo if you have never used Vim. And initially it may seem quite confusing because there are multiple modes, and how do you know where you are, right, for example. And if you actually do this for some time, say in a few weeks, it's actually not that hard. And actually you will realize, and you can take my word for this, is that it's actually good to have multiple modes, because then in each mode you can use kind of specialized keystrokes to do certain tasks, common tasks. And so something that require you, for example, in a GUI environment, to drag your mouse to mark, say, a block of text, and then go to the menu button to click on some item to do certain things. In the Vim environment, it may just hit two or three keystrokes, right? Which is much faster than reaching out to the mouse and move the mouse and locate the mouse cursor on your screen and so on. And so to kind of switch back and forth between different modes, for example, most of the time you are in the normal modes in Vim, and then you press the key I, it will jump to the insert mode where you can enter text. And to come back, you just hit escape, which is on the left upper corner of your keyboard. And you press V or Control V to enter the visual mode, depending on you want to mark a paragraph or a block. And again, you hit escape to come back. And also there's a command mode that you can execute kind of arbitrary command in Vim, that you just press the column and then execute the command. So all of this can become very natural once you use it for a while. And then you suddenly find yourself kind of operating the Vim editor without thinking. So just a comment about why using the keyboard is advantageous, right? So keyboard in Vim, instead of using the arrow keys, not only it doesn't use the mouse, it doesn't need to use the arrow key. You could use the arrow keys if you want, but it is actually much more efficient if you use the default key for moving around. For example, your index finger is on the J when you type. So for me, for a Vim user, to move downward, the instinct is to press the J key, right, your index finger, and then the cursor will move down. So your hand never leaves this kind of the main area of your keyboard. So you don't have to move your hand to the arrow key, and not to mention the mouse, right? So you avoid this kind of travel between the mouse and the key, and it actually saves you time if you edit if you spend a lot of hours editing stuff in your computer. And so So you can use these keys to kind of move around. And there's a secondary advantage of using the key, the Vim key strokes. There are several other tools also in the POSIX conformant environment that also support the so-called Vim key bindings. So once you get used to, say, move down using a J, move up using a K, and so on, there are several other applications. They also use this kind of keystrokes to move down or move up, right? So you can actually extend the habit of using Vim to other tools. For example, the Tmux command, Tmux, the tool that I will talk about later in the workshop, can also be configured to use the Vim keystrokes. So by using the same kind of keystrokes, you can use across different tools, and then you can become really fast. So let me demonstrate, especially for those of you who have never used Vim, about how to kind of switch between the modes and also some basic editing technique. So let me go to Vim. So, okay, I have two windows here. On the left window, I'm going to open a file called ucla.text file, .text. So this is the text file that I prepared previously. And this is just some text, simple text copy from Wikipedia. And when you open a file in Vim, there are certain things. Of course, this is not a tutorial for Vim, but I want to kind of mention some of the key points. The file name is displayed here, right? And below this line, there is a kind of a status line here. So it shows that this is a 27 line files, and this is a file name. And my cursor is placed here. And also, this is another thing is this is my particular setup for my Vim is that the location of my cursor, so number 4 is the line number. And unlike a standard kind of conventional editors, I'm not showing the absolute line numbers. I'm showing the relative line numbers, right? So this 1 here means 1 line below my line 6, and this is 2 lines below line 6. And this is particular to Vim because with this setup, I can easily jump. For example, I want to jump to this line, for example. One way to do this, I will press the arrow key 4 times to come here, right? But there's another way to do this. Suppose I'm far away, I'm here, my cursor is here, and I want to jump to this line, 6 line below. I can just type a 6J. 6 means I want to jump 6 times, and J means downwards, right? So you can, with like only 2 characters, you can jump to here. And so if this becomes your habit, you can very quickly jump in between your text. And also, for example, you can, suppose my cursor is here, and I want to move to a location like here, right? One way to do this, for example, is to move like this. Of course, you can argue that if you have a GUI text editor, you can just move the mouse cursor and then click here. But also, you need to count the time you reach out to the mouse and then come back to the keyboard. But also, there's a faster way to jump, say, across the words at a time, right? So these are kind of basic a way to move around. And also to enter, so right now we are in the a normal mode, so you can move around in your text to kind of look around. And once you have identified the location where you want to enter text, you can insert I. So if you notice at the bottom left of the window here, it shows insert, right? So it shows insert means you are in the insert mode. In the insert mode, you can start typing your text. So you type a text only in the insert mode. Once you hit escape, you leave the insert mode. Then now you are back to the normal mode. And in the normal mode, you cannot enter text. You can only move around. right? So all of the keystrokes you type in the normal mode is to help you to move around. And so they are not confused by the text. So they are not the data enter into the files, right? So it is actually, there are some benefits of having multiple modes, because if you are in the write mode, your keystrokes have certain functions, right? So in the normal mode, when you enter something, they are the command to move around, not the data to enter to the text. And also you can also undo easily, right? So I just press U. U is actually I press my index finger on my keyboard without reaching out to the mouse or other places. Then I can undo my actions. You can also do something like this. You can also enter the visual mode, and the visual mode is entered by the V, and I want you to watch the left bottom corner of the window. So when I enter V, I'm entering the visual mode. The visual mode is to select text. For example, I can select my text, and you see the selection is in the inverse color. And after the selection, I can copy my selection, and then I can paste my selections just like any other, and paste it by pressing P, right? So one single keystrokes. And so these are all good. And there's another operation that you can do is the block select. For example, I just want to select the middle column. And this may, for example, I know that some GUI text editors, you need to install some kind of extension. But this is actually so typical in Vim, because a lot of times maybe you are given multiple columns of data, and you just want to extract or copy out one or some of the columns. So one thing you can do is you press Control V, which enter the visual, but this is called the visual block mode. And visual block mode, you can also start to select. So you can select only the column, right? So you can select this one column, or you can just select the two columns. And then you can copy, and then you can paste, right? So you only paste the block that you selected, right? So these are some of the easy operation. And you see that I'm only hitting, you cannot see my keyboard, but I'm only hitting basically a single or like two keystrokes to achieve a certain operations quite easily, right? And imagine that if you can master this, so you don't have to even think about it, you just type, and then you can copy, paste, modify, and move around very, very easily. So, and there is another thing I want to show you, and this is another file. And this is a C programs, and this is basically badly indented, right? And so we want to fix the indentation. It's a correct program because C program does not care about the indentations, but I want to fix this. And so the way to do this is actually I just press basically only two keys. I press the equal sign, and I press the capital G, the two keystrokes, and then so basically it's basically apply indentation to the end of the files. A capital G is the end of the files. So I'm done, right? So two keystrokes, you don't even have to mark the areas and so forth, right? So this, of course, this is maybe not something that you do every day, but I'm just showing you some of the things that you can do very, very easily, and that may take you more than 2 seconds if you use other approaches. So this is kind of the basic the Vim demo I want to show you. And there are many more to this. Vim is, like I said, it's a very complex and powerful tools, and it requires a lot of time if you want to master it. But you can master the basic tools for daily use in probably a few days. The other thing I want to show you, which is a very, very useful feature, at least for some people, is you want to browse a large code base, right? So maybe you are not writing the code yourself, but you are using someone else's code. And Vim support, I think, like more than like tens of programming languages by default. And so here I want to show you that how to kind of navigate within a large code base. When I say a large code base, it means that the code, the files of the programs or script span across multiple directories and also subdirectories. And there are also many files and many lines of code. And in this particular code base I'm going to use, I think it has more than like 800,000 lines of code. And I want to show you how to navigate the large code base and also what I mean by navigate. And actually this is done by a few simple things. For a code base, you can generate the so-called tags, and I won't go into the details, but you can generate tags, and these tags can be loaded into Vim, right? And once you load into the Vim, you can now use the simple keystrokes. So Control right square bracket or Control T, this kind of simple keystroke to move back and forth. And let me show you what I mean. So let me jump to this code base. So this code base, if you run this command, you will see that it has many, many files. And if you pass the number of files into this count the number of lines, you will see that this code base has like 800,000 lines. So it's a large code base. So I want to look at the certain files, and I want to, and because in a large code base, there are function calls in the files, and I want to go to the source file of that particular function. And let me show you what I mean. So I enter the Vim and everything empty. So I'm going to edit the current directories. And so in Vim, you can also see your current directories. Of course, this is a text editor, so it may not look as pretty as your GUI interface, but it's pretty useful. So here I'm going to enter the SRC source directories. And I'm going to enter one of the, say, math directories. And here I want to go to a tutorial files. And the tutorial files, for example, I'm opening this C files. And let me make some more space here. So in here, I have my program. And suppose you are looking at a program and you encounter this function call, right? So there is a function call called, and you don't have to understand what this means if you are not using this library. But suppose I want to see the code of this, right? So this is one file, but the code for this function call is sitting in another file. And at this point, I don't know where the file is. I know it's somewhere in the file system. So if you also pay attention to the bottom line here, so this is my current file location, right? So I am looking at this file. So now if I press the key here, you see suddenly the program jumped to, this is the exact function I'm looking for. And this is in a different, totally different location, right? And so you can easily navigate the code this way. So you jump, if you press Control T, I come back to my location that I started. So you can jump to here. And when you are here, you can also, you may want to look for the location of this function call, right? This function call may not be in this file. So here, if I press this again, you see that it jumped to another file, and this is in a totally different directories and different file names, but you are exactly where you need to be, right? So, and then you can look at this function call. And then from here, you can also go to, suppose I want to also look at this function call, and you see that you are now at this function call. So you see that you can easily jump back and forth inside this 800,000 code base. And also you can easily come back to this. And so if you keep coming back at the end, it will say you are at the bottom of the stack. You are already back to your starting point, right? So this is another way I want to demonstrate to show you that the Vim's power can also be used to navigate some large code base. Okay, so let me jump to the slide. The next one I want to talk about is Git. Git is a version control tools, and there is actually a class, a Git class, I think 2 weeks ago, and I believe it's recorded. It's given by Benjamin Wingham, and this is a longer class on Git. But here, my purpose is to show you or demonstrate that Git can work well with Vim, like the text editors. And actually together, they actually work better than using the tools individually. Before that, I want to answer a question. So there's a question about how do I create 2 windows in my previous demo, and I will answer that when I talk about Tmux. That's part of a Tmux feature. Tmux is a tool, a terminal tool that I will talk after Vim. So you may have already heard about the Git and Git, or you can kind of look at the class material for the Git class. But here, the purpose is to demonstrate the integration of Vim and the Git. So Git is a very powerful version control tools, and Git also can be viewed as kind of a tool to manipulate certain data structures. In Git, in addition to your files in this small repository, I have only 2 files, but then Git maintain a number of data structures that will keep track of the differences between the changes. I like to think about the Git commit. Commit is like kind of the change every time you make as the difference between 2 state of your file systems, right? So you think of a commit is a delta, and that is the difference between the new state and then the old state. And by using the deltas, you can construct arbitrary state starting from the beginning, right? By knowing the initial state and all of the deltas, you can construct the arbitrary file system snapshot or state. And that's kind of how Git operates. And so Git also support the feature called branching. So you can work with others together on, for example, on the same document or the same code. And since people have to work independently, you can actually, for example, if you have a certain history of changes, at a certain point, your friend or collaborators can branch off from a certain common point. From this point, you continue to work on certain things, and your collaborators starting another branch, kind of work on something else in parallel. But since this is the same project, at some point you have to merge them, right? And when you merge, depending on what the changes are, sometimes it can be done easily, but other times there is a problem. And I want to show you a case when there is a merge conflict and how to resolve the conflict in Git. And this is one of the kind of the sticky thing that people who are not familiar with, who are not so familiar with Git, can find this a little bit scary, right? So, but I will show you that it's not that bad. And with the help of Vim, it can be done very, very easily. So to kind of demonstrate that, we have to consider the scenario, right? So here I have a common base here. And from this point on, so these are the commit kind of identifier. So this is how Git identify each individual commit using this unique identifier. So I have 2 branches. So they all start from this common point. So from this branch, there's a branch called branch 1. And this branch 1 made certain changes. At the same time, from the same ancestor, there is another change, right? So these 2 diverges. So now I want to merge the 2 back to one single code, right? So in this case, the master branch, which is the one here, somebody changed the function to F1, right? This is a code, for example, in this example. But in branch 1, in this diverged branch 1, At the same function, somebody named this function 1. So when you try to merge this code together, Git can see that these are all the same, so it can be merged, but Git cannot determine whether you want to use F1 or function 1, right? So in this case, when you merge, there is a merge conflict. And that needs to be resolved by humans. And you can do that, the human resolution in the brute force way, but with the help of Vim, it's actually quite simple. And so I want to show you that. And before I show you, because a window will pop up, and just to avoid getting lost into the details, when the window pop up, recall that we have 3 states, right? If you look at the initial branch, there is an initial starting point. This is we call the base branch. So there is a new change continuing from the base. So this is the change that we call the local changes. And there is a diverged branch, and this is I call the remote. So we have basically 3 states. So when the merge tool pop up, so this is Vim, right? And Vim can split windows. There are 3 states. On the left is the local branch, which is master in this case, and the center window is the base. So this is the ancestor, right? So this is the state before the divergence. And the one on the right is the remote branch. So this remote branch is the branch 1 in this case. Right? So we have 3 states. And in the center bottom, this is the window of the merge results, right? So initially, because Git cannot determine what to do, so Git basically lists all of the 3 possibilities. One is the F1. This is from the local branch. And the center one is the common ancestor, right? So this is the state before the divergence, right? And then the one on the bottom is the changes from the remote branch. So this is your collaborators branch. And so you can manually edit this out to do the merge. That's what some people do. With the use of Vim, we can do this more easily and actually also avoid mistakes. And let me show you how to do this. So the main point of this is that by looking at the 3 states, here we can basically pick and choose. We can pick and choose from either the local or the base and the remote for each of the changes. Right? So in this case, there are 2 changes. So starting from here, we are going to pick whether we want to use the local or use the base or remote. Then we move to the next change by 1 keystroke. And then we also, again, pick and choose. And it's not as complex as it looks. And also, you can look at some technical details in this link. So let me go to the Git merge conflict demo. Okay, so here is the same repository I have in the slides, right? So this is the common point, and there's a divergence, right? So this is the branch 1, your collaborator make the change, and you continue to make the new changes, and the changes conflict to each other. So there's a merge conflict. And so let's see how it looks like in the Git command line responses. So let me clone the repository. Oh, sorry. So this is the same Git history, but because this is a clone, so you see that in addition to this, you have the kind of additional text, but this is all fine. So basically, we have a ancestor, and we have a branch divergence point here. So here, what I'm going to do is I'm going to merge a branch 1 into master, right? And so let me check out branch 1. And let me check out master. And now I'm now in the master branch, and I want to merge branch 1 into master, right? So I want to do a merge. So I'm in master, but then when you say merge branch 1, we're merging branch 1 into master. So when you do this, you receive a message, and so it's something about the conflict, right? And so if you look at your files, you still have this file, but if you look at the content of the file, if you look at the content of the file, you see those markers I show in the slides, right? So this is the how Git handle the merge conflict. So instead of doing it, you can do this kind of brute force using the editor to remove the markers. That's one way. But if you have a lot of conflict, it's kind of tedious and it's very, very easy to make mistakes. So, but there's a better way. So let me make this window a little bit bigger. So let's start a command called git merge tool. Of course, this requires a certain configuration, basically a tail git that you are going to use a Vim to as the tool to merge your files. So when you run this, it'll pop up this window we previewed in the slides, right? So on the left, you see this is the local. So this is your local state. So local is the function is changed to F1. The center is the base. So this is the comma ancestor before the divergence. And here, initially the function was function 1, but in your local branch, you change to F1. On the right, this is the remote, right? So remote means this is your collaborator change. He changed to a function _1, right? So that therefore there's a conflict. In the kind of a center bottom, this is the merge results, right? One way to do this, like I said, you can just edit out the markers, but there's a better way. For example, you can easily jump between the changes. You can do this. So you press basically 2 keystrokes. One is the right square bracket and a C. Then you suddenly jump to the next change, right? And you can go back. When you are here, you have the task is to determine which one to pick, right? And the way to do this is to enter the command mode. So you enter column. So you see my cursor jump to here because I'm now in the command mode. This is called a diff get. You want to get from one of the branch. So I'm going to get from the local branch. So this is the uppercase L. So I'm going to get the local branch. So you will see that this block is going to be replaced by F1, right? Because I'm going to pick from here is. So I'm going to drop the other 2. So if you watch line 1 here, line 2 here, see it changed to F1, right? So you don't have to delete a lot of characters. Vim actually does it for you cleanly. And now I'm done with this F1. I want to jump to the next change. And this is line 10. I don't have to jump 10 lines. I can just do the right bracket and change. So I'm jump to the second place. And again, here I can pick and choose depending on which one you want, right? And for example, I'm going to pick the remote, for example. And this one, I press column to enter the command mode and diff get. And this is a short notation for get. And then I'm going to do the remote, capital R. So notice that this chunk of mass will be changed to function _1 when you press enter, right? So it changed to function press _1. So imagine, and this is a very simple code, but imagine that you have a kind of a messy, large conflict. This is a good way to fix the merge conflict cleanly. So that is the how Git can help with the Vim can help with the Git operations, right? So the 2 tools can work together and kind of save you, also reduce the chances of making mistakes. And another kind of sticky operation in Vim, and this is, you may or may not want to do this, but for a larger project, this is a common thing to do to keep your commit history clean. And let me kind of explain what's going on here. So here, again, this is the items on the bottom are the older ones. So starting from the kind of some base state, at this point, again, there is a divergence, right? So people work on different things in parallel. So you create a branch. And so in this master branch, so this is a master branch, people, from this common point, the master branch continue to update, right? So there are multiple commits. So there are changes along the way. But diverge from the same common point, there is another branch called feature one. And also there are multiple commits. Common way to merge this is just directly merge a feature one into the master, like we did in the previous case. And in this case, just to simplify or focus our discussion on the rebase operation, let's assume that there's no conflict, right? So the merge is straightforward. But when you merge, your history become something like this, right? You see that there's a divergence here, and then it's merged back. And this is all fine in terms of the final results. But for a larger project, the commit history become very noisy in a sense that you see that for this feature one, maybe you are doing some try and errors, so there are some multiple commits. But from the view of the master branch, maybe all these changes need to be merged into one, right? So you want to collapse all of this kind of small changes for feature one into just one single commit for feature one. And that operation is called squash in Git operations. And also I want to put this kind of collapsed or squashed single commit on top of the master branch, right? So I want to do that in one shot to have a clean history, right? So this is kind of another kind of sticky operations. It's quite useful to do, but then people are afraid of doing this because you can kind of mess up things. But then I want to show you that with help of Vim editor, it can be quite easy, right? So let me show you what we will get in the demo, because there seems to be a lot of screen output, but I want to kind of remain focused on the main point. So with the direct merge, the simple git merge, you are going to, the result will be fine, but you have a noisy commit history, right? So to simplify things, what I want to do is I want to merge, but I want to collapse all of the feature one into this one single commit. And I want to place this single commit on top of the master branch, right? And then I can delete the feature one history. Then my history become just like this 4 clean commits. So in the future, if you look back, you will see that on top of the master branch, there is a one commit from feature one that contain all the changes, right? And so the history become much cleaner. And this is a very small, only a few lines, but for a larger project, this is quite beneficial to do. Actually, some of the high-profile project actually require people to do this when they receive feature commits. And so some of these are kind of details that if you want to kind of trace the changes. And so here I want to show you how to do this Git operation using the Vim, and it's actually quite easy. So let me jump to another window. So here on the right, this is my situation, right? So like I said in the slides, from the divergence point, there's a master branch and there's a feature one, and feature one has multiple commits we want to collapse. And to do this, so here, let me git clone the repository first. So So this is the same repository I clone over here to perform the operations. So now I am in, I go to my feature one a branch, and I want to basically do an operation called rebase, because I want to put feature one on top of the master branch, and in the middle of the process, I want to collapse my commits. So this is done by doing the git rebase, and I want to do this interactively because I want to use the Vim to kind of intervene in the operation, and then I want to rebase my feature one branch into master, right? So when I do this, you see that I am prompted by this window, and these are the comments, update 1, 2, 3, 4. These are the comments you see if you look at the left window. These are 1, 2, 3. These are the comments from feature one, right? And so the one on the top, so it's kind of backwards. On the left, the closer to the bottom, the older the commits, right? Newer one on the top. On this one, the one on the top is the oldest, right? It's add hello 3 is the oldest commit here. And so what we want to do is to collapse all of these guys into the oldest one to become a single commit, right? And to do this, you have to change, basically to change this into, change the word pick to squash, right? So so these are the details for Git, but what I'm showing you is in the Vim, you can change this to squash, right? And you can change this to squash, and you change it to squash. So you can do this, but you see that, as you can see, it's quite time consuming, right? You type the same word multiple times, and also you can make mistakes. So if I undo this, there's a better way to do this. So in Vim, this is how the visual block comes into play. So what you do is you can block, because we are going to change all of these 4 picks into squash, right? So you can mark all of this, then you can say change, so press C, and then you can say squash, and I press escape. So you see that with that block, everything is changed at once, right? So now you save the change, and then you are given the opportunity to enter the commit message, right? So you can say this is a combined commit, and you save it, and then quit the window. And now, if you look at the commit history, oh, sorry. You can compare this and then the one on the left, right? You see that the feature one branch has been compressed into just one commit, right? So there are 4 commits here. It's compressed into one. And also it is sitting on top of the master branch, right? And at this point, you can just delete, the feature one branch from here. And let me jump to the last topic. And so before we run out of time, and so this is the Tmux, right? So all of the previous commands are command line tools. They are very powerful. And if you have to work in the HPC environment for your computational data analysis, you are recommended to master those tools to increase your work efficiencies. And Tmux is another tool that is also very powerful. So a typical connection, so a lot of times we find ourselves opening multiple windows, right, to work on the clusters or on the remote servers, because we use different windows to do different things. And sometimes it's convenient to have multiple windows display on our kind of desktop to see things at the same time. And a standard way to do this, you create a new terminal and you make a SSH connection. You create another terminal and you make another connection. And so this is all fine. The downside is that if the connection is interrupted, right, you may lose the entire session. And as some of you ask, maybe you are in the middle of doing something, you set up some environment variables, you have not entered into the shell initialization file, so you will lose everything. And also, if you have to reboot your computer, for example, right, when you reboot, you destroy your terminal, therefore also the connection and also the login shells. So it's quite fragile this way, right? It works, but then if any of this on the left-hand side or middle is disrupted, the whole thing is destroyed. This situation can be improved by using something like Tmux. So Tmux is a terminal multiplexer, and it may not be easy to understand what that means, but then by seeing the demonstration, I'm sure you will see how useful it is. So the way to use Tmux is that conceptually, you can start a Tmux server. This is quite easy to do. It's one command, and that server can be connected with your Tmux client with your terminal connection. So your terminal connection is one connection to the server, and then you can attach to the server. That Tmux server can have multiple login sessions on the server. This server is persistent in the sense that if you disconnect, right, you log out or you reboot your computer, basically you destroy the connection, this session is still there. Until next time you come in, you log in, then you can reattach to the server. And that server makes sure that everything you do here was in the exact state that when you left the sessions, right? So this is a very powerful tool. And as we have seen earlier, when you check for example, the Hoffman-2 login nodes, the login nodes have not been rebooted for like more than 200 days, right? So usually the server on the server side is super stable. So if you leave something running, like a persistent session, most likely they won't be destroyed. While our local desktop or laptop may be rebooted multiple times, or maybe you have an internet interruption, or anything happens here will not affect anything on the Tmux server. So that's kind of how it works. Hoffman-2 Tmux is also available. You can run a module available Tmux to see the versions, and you can load Tmux and run Tmux. Tmux configuration file is also, you can have like hundreds of options to configure depending on how you want it. And I will show you my configurations in the GitHub repositories. And I have quite relatively simple configurations. But you can also go crazy on a configuration to make your Tmux very fancy. So a typical Tmux looks like this, right? So in Tmux, there are several terminologies. This whole thing on the screen is called a session. And so here, this is a session name. And a session can have multiple like tabs. But in Tmux, these are the tabs are called the windows, but basically like tabs in other like GUI application tabs. On the right-hand side, there are some information about the date and other things. And everything here can be customized, right? So I'm just using the default configuration. Inside one tab, so notice that this is one tab. You can split the tab into multiple, like windows, but this is called panes. So you split into, and you can split any way you want. In this case, there's a wider window on the top, and then there's a two kind of smaller one on the bottom, right? But you can split any way you want, as we will see in the demo. And this is just one tab, right? So you go to the next tab. The next tab have its own number of split panes, or maybe there's no split. And you can have multiple tabs. You can have many, many tabs here in one session. So you see that this is very powerful. And also this remain on the server, right? And even after you log out. So, and the next time you log in, you can reattach to the previous sessions. And so that you can go back to exactly the state that you were when you left the last time, when you detach from Tmux. And so this is a very powerful tool, and actually you don't have to do a lot of things again and again because everything remains as is from last time you left. And so let me show you kind of how it looks like if for those of you who have not seen Tmux, and then you get a sense that you can dive deeper into how to use this. So it's essentially basic operations, how to split the pans, how to, and I will show you a sample of the configuration files to see that the things that you can customize. And one thing I want to emphasize is that you can configure it to use the same Vim, the editor, keystrokes, right? So you run one Vim keystroke shortcuts that you can apply to also to Tmux, right? So you don't have to run new things in Tmux. And also detach and reattach is also very easy to do, but very, very useful. So let me start from my Tmux. So everything you see previously, so you see I was showing different things in different sessions, but you see that this is a Tmux window, right? In the Tmux window, this is my session name, and I call it login 1, indicate that this is on login 1. And then here I have like multiple sessions. In this case, I have 9 tabs. In each tabs, I have different split windows. In this case, I've split like this. And in another tab, I have split like this, right? And this is another tab, and this is another tab, right? So you can kind of maintain different, and all the things here. So if I suppose I detach, so detach here. So I detach from my login 1 session, and suppose I detach, I log out. So this is on my local desktop, right? And then I can SSH login 1. And now I'm on login 1, I can say Tmux ls. So ls like to list all my sessions. So see that I have a login session already running, right? So this is the new login, but I see my Tmux session here, and there are 9 windows, right? 9 windows means tabs in Tmux. So you can say now Tmux attach to login 1. So you can have multiple sessions also, and right now I only have 1. And so this is Tmux. So if you do this, you see that you go back to your whatever I was in, right? So all of the tabs are here. So everything is good. And you can also start a new Tmux session. So suppose I call this test 1. So this is a new session, and when you start, there's only 1 tab. So you can start a new tab by like 2 keystrokes, Control and then Control B and then C to create a new thing. And you can keep creating new ones. And also you can change the name of the tabs like I did in the previous one in the demos, and you can now detach. So when you detach, if you do ls, you will see that there is a test 1 session with 3 tabs or windows, and there's a login 1, the one we had before. And then this will be here after you log out, right? And unless somebody reboot login 1, but login 1 has not been rebooted for like 200 days. So chances are that login 1 will not be rebooted when you come back next time. There's a question about, is there a Tmux tutorial? There is no Tmux tutorials, but if there are enough interest, we can create one. But this is kind of, I'm only, in this workshop, I'm only showing kind of simple operation, just introduce people to Tmux. And if there are enough interest, so if you are interested in Tmux or Vim or other tools, you can go into that survey page and enter, either check or enter the topic of your interest. And then if there are enough interest, we can certainly create a class in those areas. So let me go back to this. So this is kind of near the end of the talk. And this is recorded, so and the slides will be distributed. So essentially, the main point of this is that if you do not remember anything from this workshop, I want you to remember that the Vim and the Git and the Tmux, these are very, very useful tools and to consider if you are finding yourself spending a lot of time on like remote servers, and you can apply exactly the same technique. You can run all of them on your own laptop, desktop also, right? So you invest the time to learn this, and then you can use them also on your local environments. And these tools are very stable, so I expect them to exist and without much like a user interface change for many, many years to come. So you learn it once, you master them, and then you are good for many years, and also with like a high work efficiencies. So that's what I have for today, and thank you for your attention. And the slides will be sent, the link to the slide will be sent to you, as well as the GitHub repository with some of the supplementary materials. And if you can, please consider submitting the survey so that we have some information about to plan our future classes. Let me see if there are questions. So I think this is the end of the talk, and you can ask questions if you want, either by entering into the Google Doc, or you can just turn on your